So like I said, today we're going to go through some turning. If you have, I'm not sure how it works. I've never tried to use one of these handouts before. I've never done one of these handouts through this GoToWebinar deal. So if you look around, it might have a box somewhere. Does anyone see anything that says that there's a handout that they can click? I just need to, if you see it, let me know because I want to make sure to tell everyone. So David Wood's got it. So it's somewhere on your screen. Look around. It's called Seminar Example Part File Drawings, 12 parts or something. And what I'm doing is I'm just opening it up and I'm going to this page right here. So if you guys if you have two monitors, that's awesome. I have two monitors, so I'm going to have the drawing on my other monitor. But I wanted you guys to be able to see it just so there's no confusion on how I'm drawing it. Weirdest thing about this part is it's in centimeters. I don't know. Me and one of my coworkers drew this up, and okay, so David said it's right above the question box. You should have a handout section, so you can click and download this little handout here. So yeah, me and my coworker were putting together this little packet before I went on one of my first trainings a couple years ago, and we drew up this part, and for whatever reason, I can't remember why, he accidentally did it inside. He was in centimeters. So this is the only parts I do that are in centimeters is this part here. And if you scroll up, there's this other turning part that's also in centimeters. So, but when you're drawing parts for turning, there can be very complicated ways, or a lot of guys look at it and they overcomplicate it a lot more than they really need to. What we're going to do is we're going to draw this thing out, but we're just going to draw half of it. So we only need one side of it for turning. So I'm just going to bring this over to my other screen. Let me move some of these boxes around so I can see the thing. Give me a second here, fellas. Right. That's there for me. All right, cool. Oh, excuse me. Big lunch. All right, now, if you're looking at that part, you'll see that it's 37.5 centimeters long, and the total diameter at the widest point is 22.5. So before I really get started, I have to switch my software into centimeter mode. So over in the bottom right-hand corner, as far bottom right as you can get on your BobCAD, you should see your units. Mine's currently set to inch. I'm going to go ahead and switch that to centimeter there. And you'll see the grid lines change a little bit. Other than that, the thing with this is I really don't care if I have to draw it in millimeters, inches. I could draw the thing in decimeters for all I care. When I go to machine it, I'm going to switch it back to inch mode when I machine it. It doesn't rescale the drawing if you change it. So getting a print in millimeters, I've had guys that get nervous about it. They don't want to work with those kind of files. There's nothing to be afraid of. It's just a different number. A lot of times millimeter drawings are a little easier to draw because the numbers aren't so random in a lot of places. But yeah, you draw it out. When you're done drawing it, just switch back over to inches and you'll get to program it in inches. So you don't have to program the part in millimeters or centimeters or anything like that, because I'd be more than lost if I had to go try and program with a 1.27 centimeter tool for a half-inch tool. That's not going to work for me. So you draw it, you switch it back to switch it back to inches when you do it. So I'm going to start off by going up to the Create 2D tab, and I'm pretty much going to draw a rectangle that represents the entire one half of my part. So when I go up to rectangle, I'm going to say the length is 37.5, and the width is going to be 22.5. Now, that's the diameter, and I only want to output the radius. So I'm just going to say in this box divided by 2. All the boxes, if you didn't know it, all the boxes in BobCAD are calculators. So any calculation, any math you got to do, all you got to do is type it in, as long as it's pretty simple math. If you start getting into some crazy stuff where you need scientific calculators, well, there's a calculator on your computer for that. From here, we want to place it in the right position as well. So the front face of our part, when we're talking about turning, should be placed along this line here. So I want to line that face up. Now, since I'm only drawing half of this part, I want to try and get the front or bottom right-hand corner there on XYZ0. So the easiest way to do it is just to click this button right here that says bottom right, and that'll put it on XYZ0. Then we can hit OK and cancel out. So that's the entire rectangle that we got right there. So now we're pretty well just going to start using parallel lines to line things up. This is the center of the part. this is the front face. It depends on your print. Some prints you'll get them off the back face is where everything's parallel to. For most of my stuff, I do everything off the front face, or at least where I'm going to be taking my measurements from. So I'm trying to follow how I did it there. So the first thing we want to do is I want to line up with the first step right here, because this is the highest point. I want to get us right here first. So if that diameter is 12.5, move that back over there, I can go up to the line function, and then right here is the line parallel function. So I'll click on that. So I'll say that the distance is 12.5 divided by 2, because it's giving me a diameter. So from here, I just click this bottom line, and I go straight up to right there. That doesn't, yeah, I guess that seems right. It seems small. But there's a hole through the center of this as well. I got to move my screen to see it. Looks like it's 6.25. So I can put that in now. I'll put it in a few minutes. So this is to the top edge here. Now I'm going to go with the same distance of 6.25 actually, because we got to go from the front face here straight back. So we're going to go straight back that far. So this will be the first ledge, and then we'll have a drop down for the groove there, come back up, and then we'll have that angle go wherever it needs to go. So for the other side of the groove, I'm just going to change this dimension to 9.38 and go from the front face straight back. So that's the width of the groove. Now the height of the groove, if you look on that drawing, it's a 1.88 deep. So I'm just going to go dimension 1.88, or distance. Grab this line that I already created, and I just want to go down 1.88. So now, you know, you'd never want to get rid of the bottom line or the face line until the end, because most of the time we're going to be using those for our parallel line. So I want to try and keep those there if I can. But at this point, you can also start thinking about how you're going to clean this up. So I'm going to go up to Utilities and then Quick Trim. And I'm going to get rid of this, this, and this. So there is the groove right there. So then I can get rid of that, that one there, and then these two right there can go. So now I have the little groove in there. I'll worry about the radius that I got in the corner there in a minute, but there's our first groove. The next one, we have to go back to a distance of 10.81. And so I'm just going to go to Create 2D, and then Line, and then Parallel. So right here, we just say 10.81. And so we're just going to go from this line straight back 10.81. Now, before I exit this feature, I also want to go back all the way back to here and find out where this 25.44 is going to land me. So 25.44 from the front face straight back. And there we go. So this will be the angle that we create. So I'm just going to go to Line. And if I hover over this, it's not, I don't know if it was in version 30 like this, but it wasn't in 29. I know for a fact it wasn't like that, but it'll now give you the intersection when you're touching for snap points. So as I touch this line, it'll actually tell me where it intersects with this line. So I'm going to grab that there. Hold on, cancel out, grab my line again. I clicked earlier. So right here, we're going to click on that point and say, go to this intersection. And then I can just cancel out. And so pretty much now that I've gotten that portion of it, I can start trimming a lot more, but I'm going to just finish it out. I got to offset a little bit more here and then do the back groove. So let me move this box again so I don't need it. I don't need the chat, right? You can go. You can go. All right, there we go. So right here, I'm just going to go ahead and do a line parallel. And this time we're going to go back 28.13. And this is going to take us to that back edge there. So now we're going to go in. We're going to then take this one and go down a little bit more. And then it's mirrored. It's the same on the other side. I don't know why I didn't dimension it, but it's the same on both sides. So if I go in and say 6.25, I can go from this side in. That's where the groove's going to be. So now I'm just going to do the same size groove as 1.88. So I'm going to say 1.88 for this down to here. So I pretty much have everything drawn now. I'm just going to go back up to Utilities and say Quick Trim. And I'm going to start trimming out the things I don't need. So I want to keep this, or I want to get rid of this right here. So that gives me the groove. I'll get rid of this here and this here. Yeah, it's where it's actually where the way I drew it initially there, Larry, is that's where the corner would be, and I'm going to add the fillet in. It's not it's kind of weird how you see it, but it actually lines up with where these two originally met. And then I'm going to go put the fillet in here in 1 second. It might make more sense to you here in a second. So let me trim this thing away, trim this. Whoops, I got rid of too much on a minute ago. That one's got to stay. So this can go, that can go, that can go, that one. So that's the back side. I can then get rid of this and this, so that you can start seeing it come to start kind of seeing it come to shape here. And then I'm going to trim off this right here, this right here, this right here, and then get rid of the top half of this, this, and then I can get rid of this right there, and then this and this. So now for that fillet, I can come in and say create 2D fillet, and I'm just going to put in the radius of 2.5. And then this is what we got going on. So the fillet, or the function that I used, is going to pretty well kind of where that sharp corner would have been made. And then we could just slap the radius on it. I don't remember what I put in for these small fillets. I don't see them. Oh, 50 or 500. So we're going to go with another radius of this time 0.5 for the bottom, all these internal little radiuses here. Now, a way to make this a little quicker for you, by the way, is if you got the picking method set to between two entities, you have to click both entities every single time. But if I say single corner click, I can actually come in and click on the corners that I just want to add that little radius to, just like that. So now we have a radius on it, and yeah, there we go. So you drew the part out, you got it drawn out as a 2D version of that part. So now we would be able to take it. Right now we're ready for machining. This is a done part. But what we may want to do is make a solid model of it. And the benefit of having a solid model for just about any scenario, whether it's milling or turning or anything that you do, is when you launch the simulation, this having a solid model turned on inside of our CAD window here kind of unlocks the workpiece option. So we can actually see our part inside of the simulation. That's another little thing. If you ever launch your simulation and it has a weird blinking bar that pops up, that's usually caused because the solid that's trying to get brought into the simulation is broken into a bunch of surfaces. So if it starts blinking real fast, that's because it's trying to process each individual surface as it brings it in. So you have that one, that's one thing. If you have that and it takes a while for the simulation to load, especially when you are doing a broken solid, as it loads the sim, it's trying to bring that all in, process everything. It takes a second. If you turn off the solid model before you launch the simulation, so you just turn off the layer with the solid model, then launch, it'll launch a whole lot faster. The benefit of having a solid model for turning or even milling is the part that I create should be a copy, exact copy of the final part, the part that I want off the machine. And so what I'm able to do is, as long as I drew my part correctly, I can show it as a workpiece, and inside the simulation actually see the difference between what I've cut and what the part file should be, according to how I drew it. So to make this into a solid model, I always make a new layer first. So in the layers, I got the CAD layer by default. I'm going to right click and say add new layer. And then right here, I'm just going to call it solid. So just put solid there. And I just want to make sure the check mark sits on it. All right. So now we can go up to the tab up at the top for create 3D. And then I'm going to go right here to revolve. Now with revolve, it allows me to choose a revolve curve and a rotation angle. So I'm going to say 360 degrees. And then I haven't switched my coordinates into lathe mode yet. Top 2.5 radius. Where's that? Oh, right there. Thanks, David. Give me 1 second. He just pointed out I forgot to put a fillet on here. And the thing is, you want to put these fillets before you go and do the revolution, because it's the solid fillet is not a really, wait, hold on, hit undo, wrong one. This one right here. Okay. Bam. Believe it or not, I made this part. All right. So there we go. So when we get in, we're going to create our solid. So again, you go to utilities, 3D, revolve. And you want to make sure to try and get the fillets. Anything you can add onto the part before you have the solid model is going to be way better than when you have the solid model. The filleting for 2D here is way better than filleting for 3-axis, or for 3D, just because it's a 2D shape. It's just easier to fillet, less going on. But it's easier then to revolve that kind of rotation to make it all work. So I'm going to go with 360 degrees. Now, the only thing about this, and I didn't put the hole through the center because we could drill it. There's a bunch of ways we could do that. But with this, I don't want to pick this middle line. The only time I'll be willing to pick this middle line is if it's a hole. So an example of what this part's going to look like without the hole in it would be you'd start on this side here and you'd chain all the way around to this side here, but you will not use this middle line. So I'm just going to click here, follow this chain to the end of the last chain. Now, when you get to the last chain, and you don't actually have to have your mouse follow it, just so you guys know. So when you get to the last chain, you're going to find about where the middle of the line is, and then you want to go past it towards the end of that final chain, then hold shift and click. And so that's going to give us a preview of what that part's going to look like. Now, again, this has no hole in it. So that's going to be just like that. Now, if we did have a hole in it, well, then we wouldn't have a perfect center line. But I'm going to go ahead and put the hole in. So I'm just going to go to Create 2D and then Line with my parallel again. And this time the distance is going to be 6.25 divided by 2. And so I'm just going to go from the bottom straight up, just like that. And now, again, I'll use my utilities, quick trim, and then I'll just trim off that, that, and that. And the best part about doing it this way is now when I go to do the revolve, all I got to do is hold shift, click the geometry, and it's going to do it. So I'll go create 3D, revolve. We're still at 360. So now I can just hold shift. It really doesn't matter where I click on it. Oh, I held shift to it. I got to pick the whole chain. Hold on. So you got to go here, around, hold shift and click. I guess it doesn't want me to chain just by holding shift anymore. So there it is. We got a preview of it. And if we like it, we can go ahead and hit OK. Now, the benefit to creating a solid model to this, or do you need to create a solid model? Not at all. You never actually need a solid model for turning. If you have a mill turn, yeah, that's a different story, different kind of machine. But we don't use the solid model when we're actually machining this. So it doesn't help us in any way. So what I do is I create it, and then I immediately turn it off. So the only time I really want to mess with that is when I'm doing is when I launch my simulation. We're going to see that here in a minute. So that's how you'll draw your parts. Basically, again, start off with a rectangle and just start using parallel lines. And it works for not just turning drawings, but turning drawings, it works really well. For a lathe part, that's a really nice way to draw. Same thing would be this part here. You can draw it the exact same way. This one's kind of goofy because it's got this front radius on the front here and on the inside of a radius of like 180 centimeters. So it's a real shallow little radius. There's a trick to that one. We'll draw that one out sometime. But a lot of these parts you can draw with that same kind of method. If I drew out a rectangle that was big enough for this, I could start offsetting my lines or paralleling my lines and then turn it into a solid model. You can do that with, if you've ever been to my class, we draw this part during the class, and it's drawn out. Basically, you draw this view of the part, and then from there, you're able to take the part and turn it into the solid by starting your extrusions and just creating the features that you need through extruding. So it works out really well. It even works on a lot of this stuff. You wouldn't start with a rectangle here, but you definitely give yourself some lines that you could be parallel to. Works great on this part here. Works just fine on this part. You can line all your stuff up. Works all right on this one. You draw it out in more of a view like this. Start with your rectangle. This one works great, and then this one it doesn't work at all because it's a round part. So you draw circles. You'd start with your arcs on that one and kind of base everything off that. So there we go. We got the part drawn. You can save it if you want to. And then right here, I'm just going to jump over to my example part. So the example part that I got here, it looks something like this. Mostly, it's just got a lot of different grooves on it. We can do a thread on the ID here. It's got an ID groove. We can do some boring. So there's a lot to do with this part. Before we get started with this, the first step after we've got the part drawn is we have to create our stock. So I'm going to go ahead and turn off the solid and have just my 2D on. I'm just going to go down to my cam tree, right click on cam defaults and say new job. Remember with 31, there's a cam tab now too. So if you didn't want to go over here and click new job or go right click and hit new job, there's that option there. There's also this little icon right here, just under the word cam in my cam tree here. It's a little icon that lets me start a new cam job. So I can just click on that, tell it I'm turning, And then the BC2X lathe, I get this question a lot because people need different mills. You do not need different lathes. It's a 2-axis lathe. If you got any more than that, you're starting to talk about mill turn, and that's a different machine and a different build from us here at BobCAD. That's a lot bigger kind of build. So the turning, you're pretty well always just going to use the BC2X lathe. The most important thing here is when I hit OK, the post processor. We're not sending out a bunch of post processors for version 31. If you look inside the folders when you first install, there's only 2 post processors that come with BobCAD for turning, specifically turning. There's going to be more for the milling, but we stopped giving posts, standard kind of. We stopped standardizing our library just because things are getting tweaked too much, and it's tough to keep up with some of the changes some of these companies are making. So we went with some of our generic ones. You can still go online and find most post processors. All our OEMs are online, so you can go on there and find them. It's just BobCADsupport.com. Which I think is where you guys sign up for this anyway. So on there's a downloads page that has post processors that you can go download if you don't have one already. If you do have one from a previous version, it should work, but it's definitely worth testing once. Test it a few times if you want. See how it works. If you see any bugs pop up, any little things that aren't your normal way of running it, let the tech guys know, and they can get you in touch with the posting department and have them tweak whatever they need to. The problem with going from one version to another is sometimes we change things inside the actual posting engine. And so some variables that you might have used in the past are no longer available, or they've been replaced with some other usually better variables. That's really the only reason we'd ever take stuff out like that, is if we've redesigned it and made it a little bit better. So yeah, so you'll pick your post, and that's the most important thing. Everyone's going to have a different post. You got to think this post processor, all it does is it's a translator. If that's how you want to think about it, this just translates what BobCAD does into the code your machine is going to understand. So it definitely needs to be specific. Now, the proper way of doing your jobs, and this is for any job you do, the proper way to start the job is to set up the tools that you plan on using before you actually ever get there. And so I like to set up the tool crib. Now, I'll start by saying I do not even come close to setting this up every job. But jobs like this, I definitely want to set up, especially with the threading on the ID, the groove on the ID. I got to make sure I pick the right tool. So I'm going to go in. We'll do an example. I already saved a tool crib for this one, but I'm going to go in. If we go into our tool crib, it should be empty now. I haven't done anything in here yet. I will import a tool crib in a minute, but just so you guys can see how this all works. I'm going to go over here to the rough. You know what? Let's go to boring. Let's go to boring here. I don't think we'll need it, but this is the one I would tweak the most. So let me go in and I'll say, now that I'm in boring, I could say I want to add from the tool library. And I can go in and I can pick these different boring bars. I could also add a new one. So when we're adding this, you have to start thinking about kind of the holder that's going to go along with it. And depending on the hole that I have that I got to cut through, I got to make sure that that holder is going to be able to even bore the center of this thing out. So when we get in here, we can start defining it. You know what? I'll leave this CNMG. I'm going to make my insert a 1/4 inch instead of a 1/2 inch, just a little bit smaller. And then right here, we have the tool holder. So when we go into the tool holder, we have a few different designs of holders. You could start looking at some of these. You could even draw custom holders and actually pick the geometry for some of those custom holders. So I'm going to leave this one here. I should be able to, I have a tool already made for this specifically that's got the proper holder on it and everything. But you'd be able to go in, add tools to it. The library for turning tools is not nearly as extensive as the library for the milling tools. And a lot of that's because you don't, not everyone saves their milling or their turning tools. It's so easy to just punch them in on the fly because you can just define, if it's a VNMG, you just change it to a VNMG in BobCAD, and then that's going to recreate the tool. The only problem you really run into is making sure that the holder is the right holder for that insert, in which case you can set up specific holders for specific inserts, and that's a really good way to get it done. So there we go. I got that. If you pick one, you hit OK. It's going to bring that boring bar in just like that. And then from here, I can actually go in and change how it's positioned, how it's sitting. So like this, I can go to position number 8 for an ID bore to come in. Now, you really don't have to worry about the mounting orientation. That's more so going to be pulled from the geometry and everything. You'll see it in a second. So I'm going to go ahead and just load up a tool crib real fast that I've already set up. So I just saved it. So let me go here. Where the heck did I put that? Oh, it's in my webinars folder. All right, so it's down here, webinars, and there's my tool crib, hopefully. Oh, there we go. Cool, it popped up. So I got 11 tools going through here. Some for roughing, some for finishing, bunch of different groove ones because some are on angles, all this kind of stuff. So you can see all the tools. Let's see, here's our threading inserts, grooves. So there we go. So now I'll go ahead and hit OK. We have the tool crib set up. So the benefit of setting up the tool crib before you start the job is, well, now I know what tools I plan on using. And the bigger benefit is BobCAD has a very good chance of picking the tool that I want to use when we do set up a tool crib. So I like to let BobCAD do a little bit of the work for me if I can. Otherwise, I'll set it up myself. So now we get to start with the stock. So I'm just going to right click here on the word stock and just say stock wizard. And so we'll see the stock diameter right now is 2 inches. If I make it 6 inches, I think we're a little bigger than we need to be. Let's go 5.25. Yeah, that's a little bit more reasonable. Now the length, I want to go back, let's say 6 inches. So I want something to hold on to back there. And then the only other thing I want to do is if there's material that I want to face off, you can add that material to here. So I could say there's 100 thousandths of material that I want to face off. And what that does is it shifts that part forward, shifts the stock forward 100 thousandths. And then we can go ahead and hit next. Now, when we hit next, this is all our clearances. So your face clearance, it's going to wrap it in front of that part 1 inch away. The OD clearance is also 1 inch away, but the ID clearances are going to be 50 thousandths. And you have to have a smaller number there. You got to think, if you come off this wall way too far, you're going to take the back side of the holder and slam it into the other side of the wall you just tried to finish. So make sure you set up the ID with a small enough, safe but small amount so it doesn't back away too far and gouge up the part. So hit OK. And now I'll go ahead and blank out that stock. So from here, we could start actually tool pathing this. And I'd start always with a lathe end face. So I'm going to do a lathe end face and select my geometry. When you pick the geometry for the face, if you're used to the older systems, and you guys, if you want to send me a message, if you're, has any of you not used the version 31? You own it now. You may not have used the version 31. You're still using an older system. Any of you guys still using like 29 and previous? Not even 29. 29. I guess you could go previous. In the past, let me just say, in the past, we didn't really have a way of letting BobCAD do any automatic work. So one of the problems was if all I had was a line this long to face, in the past, when we'd choose facing, all it would do would come in and make a little face on just that little line, but it wouldn't go anywhere else. It wouldn't go any further into the stock or above that line or below that line unless you added extensions, or really, we didn't even have extensions then. You had to add leads. When we're doing a lathe end face, all we're really looking for is kind of where do we need to stop. So did I pick the right? Yeah, front face. So I did pick the right one. So it picked the line, and basically all that line's there for is not telling it a length in X. It's telling it where it needs to cut to in Z. So there's our rapid plane. The feature type, because I picked the lathe end face, it's always going to be on the front face. And then right here is the important part. This is the constraints. This is how we get the tool to cut the entire front face instead of just the one little line that we selected. So if I leave it on from stock, it should recognize and cut from the top of the stock down the front face of the part. So I'm going to go from stock. From custom lets you go in and type in a value, whatever value you want to go. I don't know if it's from center, but it's a value. That's where you're going to cut up to. I believe it's from center. So it'd be 2 inches from center down would be getting face, but anything above 2 inches would get ignored. So we'll go from stock. Now the extensions, I like to use extensions on the front face because it allows me to have the tool come in kind of a little early, not really early, but instead of it just meeting here and plunging down, I could say start an 1/8 inch higher than the part, feed kind of where your position is and then make your cut down. So I like to do a distance above. Now I also like to do a distance afterwards because when it hits the center, if I let it stop right when it hits the center, it's going to leave that little nub on there. So I could go in and say add another 1/8 inch or whatever's going to get me past. This isn't perfect. I could go probably a lot smaller than that because I think I only have, I'm going to be running pretty well a 64th or a 32nd radius. So I just got to go past it by enough to clear that off. I'm all right with an 1/8 inch. Next, we then have the strategy. So this will give us a rough and a finish pass. In this case, I want to get it done. So I really don't care if we do a finish pass. I really don't care if we do a rough pass. If I'm doing it in a single pass, it's going to be fine. But I'm going to do just the rough. It's easier to just set it up. So I still get multiple cuts, but when the final cut's done, it'll be to size. So I don't have to do a finish pass afterwards. So we got separate moves and canned cycles. This pops up all the time on, this stuff not working. The big thing with this is not many of the posts by default have all the canned cycles in them. Some of them might have a few, but not every post we create has all those canned cycles. So if you are trying to use canned cycles for this stuff, you have to get in touch with our posting department, and they'll be able to go in and set up the canned cycles for you. All you need to give us is an example of how they're being used, and then the description of them. You can usually find that kind of stuff inside your manual, or if you're lucky enough to be able to search online or call your machining dealer, then they can usually provide you with some of that information as well. So I'll leave it on separate moves for now and hit next. And right here's our rough tool. So you'll see it pick tool number 1. If we go up to the tool crib, we can pick whatever we want. I really don't have too much to really mess with. So I'll go right here to the finish and just pick this CNMG. Hit OK. That's tool number 1. Right here's our patterns. So on the patterns for this, you could either do a standard cut where you're going to start at the front face of the part and then cut your way back. Pretty well the way we all picture how we do our turning. But you can also do an offset. So this is actually going to go in and start kind of, I'll call it chipping away at the part kind of. It's removing the material, same amount. It didn't change the depth of cut at all. But it changes, the amount you take off. So something like this with this little cut here, there's a lot of material that's going to come off when it does go to hit this, as soon as it passes this point. I mean, part of that's going to be your depth of cut. There's a lot of things that factor into that, but I primarily stick with the standard option. Now for the sorting, it's either you do it as a standard, so from front face to back, or you can do a zigzag. And with this one, it's a lot more back dragging on the insert, so there could be holder collisions. There are going to be so many things that don't work with this one. I don't use it too often. Special scenarios, I get some guys that do a lot of turning with basically a grooving tool, and that zigzag does a great job with some of those tools. So definitely something to play around with, see if it's going to be a benefit to you. Down here we got our compensation. So you got system compensation, machine compensation. The system compensation has 3 different kinds of compensation. So you have off, you have on without collision detection, and on with collision detection. So just so you know, if you're just trying to get a basic idea of what the part's going to look like when you run it, if you turn on without collision detection, BobCAD's not doing anything in the background to try and avoid collisions. It's not doing anything for us, but it's going to calculate very quickly compared to the on with collision detection. On with collision detection just takes a lot longer to calculate, but the finish and what you see could be a better view of kind of what you're seeing. The on without gives you a basic collision checking. It'll make sure the holder's not dragging through the part, but it's not really doing much more. This one, I could even say, make sure the holder doesn't collide with the part. So I could say use the tool holder as well. Right here's our machine compensation. So this would be if you wanted to use a G41, G42, take care of any tool wear you might have, and comp it into the proper size. You still have your machine compensation as well. Next, we then get the parameters page. So for this one, I am going to do just the whole thing with the rough pass. So I'm going to say, let's do a depth of cut. 50 thousandths is fine. It'll just be 2 passes to get me there. Now, the rough allowance would be kind of allowance left for a semi-finish pass. We're not fully ready to finish yet, but the rough allowance lets me leave a little bit more material on there. And then I also have my finish allowance below. Now, because I don't have a finish pass and I don't need to run the finish pass, I'm using this roughing tool for everything. I'm going to take these allowances and just put them at 0. So it's going to finish the whole front face of that part to 0. And then we have the overlap. I'll talk more about this when we get into the turning here in a few minutes. There's some more there, corner types. We really don't need to worry about some of this stuff for the facing operation. It's just there because it's always there. Every other feature has in some way, some ability to use a lot of these other features. So, but for this one, I really don't care if it overlaps its face cut. I just wanted to do the face cut. So right here we have our default rapid approach. And when you're talking about your rapids, there's a few different places to rapid to and from. On the approach, you could say just do the default rapid approach. So pretty much just get the tool to the part. We could also say go to the OD clearance, and that's where I want you to start. Or you could say I want to go to the ID clearance or the face clearance, whichever one you want to do for your clearance. You can also do rapid moves defined by a certain point, and then you can tell it how to get to that point. So you can say I have a point wherever, and I want it to get to that point by going X first and then moving my Z. And you got to be careful with this, especially more so on the exit. So you have a default rapid on exit that's just going to always go to the tool home. It's going to leave, go home. When you go to the other options you have, or this one's going to go, yeah, pretty much tool home. That's what it says, right? Yeah, home position. So that's where it's going. And then you have the tool home. Now, what you're looking at really is these letters on the end. When it says X-Z, it means it's moving the X, then it moves the Z. And the second one there, it's moving the Z, then it's moving the X. And the little one there that's got no dash in between them, that's doing an angle out. So that one you got to be careful with. I've had multiple people that called me up and told me they made a little mistake and they accidentally picked one of these options that was X then Z on the ID of the part. So it tried to rip through the part, try to go back up through the part to go back home. It didn't end well. Last guy said just the whole machine had to be recalibrated and everything. So you got to be careful when you're picking these. Really, the defaults are pretty good places to start at. The only time I really don't trust the exit on the when it's leaving is when I'm working on the ID. If I'm working in an ID and I'm worried about the tool coming out and just something going wrong, just something happening. One, watch the simulation. It's going to happen in the simulation, always. But even then, if I'm still worried about it, I can go in and change this to something like no rapid on exit, or override it and say I want to make sure my X moves before my Z moves, or make sure my Z moves before my X moves, whichever one's the right situation. Right, here's our leads. So with the leads, we got parallel lead-ins, we got perpendicular lead-ins, horizontal, vertical, we got an angle, and then a custom. So you can actually define it with your X and your Z. With the lead out, same thing, parallel, perpendicular, horizontal, vertical, angle, or custom. So I'm going to go, we'll go angle out here, and then I'll hit next. The advanced feed rates, you guys will see these all the time. Pretty much every week we do one of these webinars. At some point, there's going to be a page that talks about the advanced feed rates. So the advanced feed rates allow me to convert rapid moves to feed moves. So instead of outputting any G01s, or whatever your machine calls them, G1s, it's going to output G00s, but it's going to have a feed, or so it's always going to output instead of a G00, it's going to output a G01. And on that G01 line, it's also going to output a feed rate. So you're overriding the feed rates, and you're overriding, there's no more rapid moves that are going to get called out. They're going to be converted to these feed moves. So you can set up your own feed rate specifically for when you're doing your feed moves. The leads next to that, or just below that, you got lead in feed rate percentage and lead out feed rate percentage. Those are used primarily to slow your tool down when it first engages with the material. So you can go in and say your lead in feed rate is 50% of your normal cutting feed rate, and it's going to slow that entry in by 50%. So there we go. When I'm all done, I can hit compute. The face, for some reason, when you're using the option for the collision checking, the on with collision checking, use the tool holder checkbox. Some of these facing programs take a long time to calculate. I don't know what it is. I just talked to I just put in a request from my to my development team to see what's going on, but it just takes a while. It could be something on my system that I haven't changed. Maybe my tolerance is way higher than it needs to be. But it doesn't take too long with some of these other tool paths. So I just put in a request and I'm going to see what they say about it. So cool. I thought it'd be done calculating by the time I finished talking. Sorry, guys. Give it a second. By the way, if you guys have any questions at all in the meantime, make sure to put them in that question box for me. And we can talk. You can ask random kind of random questions if you want. I don't want to go too far, so if you do ask a real random one, I will get to it. It just might be at the end. All right, there we go. So here's our part. We got two face passes on there, and we're done. I'm going to go ahead and right-click on that feature, lathe end face. I'm going to say rename, and I'm just going to call it face. For some reason, I don't know what it is about turning, but with turning, I absolutely have to rename the features. Mostly because they all just come out with the same name. They all come out with feature lathe turning, and it gets real confusing. I do it with my milling as well, but I really, for some reason, make sure to rename these things, mostly because I just want to blank them out, shrink them up, move on to the next one. So I'm going to now do the turn rough. So we're going to right-click here. We're going to go down to lathe turning and then select my geometry. Now for this one, I want to go just from this angle here, right there, to the back of this side here, to the back end of this. So what I want to do is I clicked on the first one, follow the chain all the way back till we find the midpoint of the last one. And then I'm going to go a little bit more to the left. All right, I want to go past that midpoint a little bit. And then I hold shift and I click. And as long as our geometry is good, no breaks, no overhangs, it'll connect between the two. If there is a break or an overhang, it's going to stop whenever it gets to that certain point, and that kind of tells you where it's going to happen. If you have bad geometry, if you hold shift and click on your part, wherever that chain stops and it turns back to your normal blue, that's usually where there's a problem. So be careful, but definitely if you get a problem, go fix it now. Don't try and struggle through it. I've done that before. It never works, and you just end up ripping more of your hair out throughout the day. And I ain't got much to spare. So make sure you fix the geometry before you get there. And then when you're done, you can hit OK. So now that we got the geometry selected, we just next our way through. Now, I cannot emphasize how important this page right here is. It controls so many things that it doesn't seem like it's doing much, but when you start doing ID work and you start doing back facing and front face, all these different things, face grooves and stuff, you can't just leave it on OD. The OD setting here is really telling BobCAD what orientation the tool is going to be in as we cut. If I switch it to ID, well, now the tooling page just changed. It's going to have a different feature. It's going to have a different orientation on its tool as well. So you do want to make sure you set up this feature type properly. Here's the thing, though. We got a lot of grooves on here. I got this big angle groove here, and I don't think I can leave this one out, which I'm okay with it cutting a little bit of this as long as it's not gouging any of my walls. But this turn groove here and then this face groove here, I can actually go in and I can make BobCAD ignore those. That's the reason we're able to pick the geometry the way we were just now. For some of you guys, Raymond Pickle, it's been a long time since I talked to you, buddy, but you might remember back in the day when I was in tech support, probably asking some questions about lathe. But if you had grooves and stuff, you had to put a line over them. You had to take the grooves out. You had to put them on their own layer. They had to be their own little piece of geometry. Now we don't need to get rid of that geometry. We come in. If you check mark where it says remove primary undercut, BobCAD is ignoring all turn grooves. If you put a check mark on remove secondary undercut, we're removing all face grooves. So as you go through this, if you put check marks on both of them, you're avoiding turn grooves and face grooves. I can't, for whatever reason, I'm blanking. I just cut this part last week. I don't think it leaves out angled grooves. I think it's just strictly turn and face. We'll find out when we compute this. But it may leave out the angle groove. I can't remember anymore. So right here, then there's our constraints. Now, for the most part, on your roughing cycles, when you're doing your face, you're doing your main rough, before you really get into starting to do the finishing work, like your grooves and your threads and all that stuff, primarily I go off the stock. My constraints are going to be set from the stock. I want BobCAD to look at the stock and cut all of it. So I say from stock. From geometry is a lot better when you start working with grooves and stuff. So we'll look at that in a few minutes. Now on the extension here, I always like to give a little bit of a extension. And I primarily use the extensions as leads. So I just come in, I tell it what size I want to make that, and then how much extra I want to go past the end of the part. And when I'm all done, I'll hit next. All right, right here we got our strategy. So you got a rough pass, which is just a rough. You got the rough and the finish pass, which is the rough with a finish pass. And then you get the pattern repeat. So basically a bunch of finish passes that you can have work into your final finish size. Pretty much an offset style pattern. So the final one's really the finish. And then from there kind of just offsets that tool out. Gives you a couple passes to work it in. I'm going to go ahead and do the rough with the finish here. So I get the rough with the basic finish. We'll be able to use our CNMG for the rough. And then we'll switch to like a VNMG or maybe we'll just use the same tool. We'll figure it out. Next. Posting, you got separate moves, can cycles once again. Next again. All right, roughing. So here's the tool. What's really nice about this and what they changed in version, it was 29 or 30. I don't know, for those of you who have possibly not seen this. There's a button here that says show tool holder. So I can see what this insert and holder combo is going to look like when I actually go to machine this. So I got a pretty good idea of it. Right here's the reference point. So I'm always going off the corner, and that's based off the hypothetical tool tip here. So you got to think, if you went and touched off the front face of your part with the front face of this tool, that's going to line up your Z, and then you touch off the top, that's going to line up the X. And what we're actually creating, or what your machine's creating then, is this point where the two would meet. So it's given that hypothetical tool tip. The nose radius right there, that's the radius on the tool. And then the inscribed circle diameter is kind of the diameter of the insert. So this is a 1/2 inch insert. If you were to go and make a circle a 1/2 inch, it would hit every one of those walls. If you wanted to make a smaller one, 1/4 inch, whatever you got to put in, whatever you put it into. Right there's the tool label, and then your orientation. This is a whole section for your tool orientation. So for this part, you have 4 different orientations under vertical. You'll have 4 different orientations under horizontal. In the old systems, there was orientation 1 through 4 for turning, and then facing was 5 through 8, which when you're inside the tool crib, we still do call it that way. But primarily, these are going to be, the 5 through 8 are going to be on your facing geometry. So right here, we have the vertical. There's orientation 1, orientation 2. So that one's primarily trying to look to cut from the back face back towards the front. You have orientation 3. Could call this an ID cut, but not really. The holder's going a little weird on us. Same with number 4 there. So when we start switching, we can then do horizontal. If you go to orientation 1, that'd be kind of doing the OD, not the way I'm going to do it. We got number 2, so this one's going to go from the front face back. Number 3, you start getting into a backside ID kind of finishing, but not really something we're going to do. And then right there is number 4. So I primarily use number 4 when I'm working on my ID work. It's going to let the front face of that just run right in, clean up that top edge, and work. Now, we're going to leave it on vertical, and I'm going to put it back to position number 1 because that's the orientation I really need this thing in. Right here's the tool number and then the offset. So you have override offsets. If you want to change that, you just type in what you want to do for your offset. Spindle direction, clockwise, counterclockwise, coolant types, and then feeds and speeds. We got 2 different ones. BobCAD lathe, we don't figure out we don't even try and calculate the feeds and speeds for the lathe portion of this. But just so you guys are aware, if you choose a drilling job, it will pick up the feeds and speeds. There is a material, it's just hidden right now under my stock. I got to expand that thing. It's probably still 1018 carbon steel because I don't think I've changed it yet. But the only time the turning section of BobCAD is going to use those feed rates and that material is when you tell it you're drilling or center drilling, all those kind of ops. So drilling primarily. Tapping. Tool parameters have changed. No, I don't know what changed about that, but all right. Yeah, go ahead and change it for all of them. All right, so right here's our pattern. We got a standard cut and a standard sort. And then I'm going to just do the on with collision detection using the tool holder. You can see that this is going to start getting really, really repetitive very shortly. There's our depth of cut. I'll go 50 thousandths. This is what we're leaving for the finish pass. And then right here's our overlap. So I'm going to overlap back to the previous cut. So you can see the difference with this. I've had a lot of guys that say that have asked me about this because they say they never noticed it. No overlap. It's not going to have any connections between them. There's going to be no line that links this to this. The 2 previous cut option, when it comes in, when you see this lead, most people think the tool is going to come in and then it's going to lead out there and go. That's not what's happening. This lead here is actually for this line down here. So it's going to cut up and then leave during that one. So for this one, it's going to cut along, follow this back up the part to its previous end, chain out, and then leave. So 2 previous cut, no overlap, whichever one you want to use. And then we got our corner types. We can go round or sharp, trim to stock. I'll talk about that some other time. And then the rapids. So same kind of default rapids. I'm pretty much going to keep the defaults now just so we can get some tool pathing done on here. Leads I'm all right with. Advanced feed rates, I ain't changed them. And then this one, I'm just going to switch it up to a VNMG. And it'll ask me, the tool parameters have changed. Do you want to keep the change for all the operations that feature this tool? I didn't read that right, but it makes sense still. So right here, I don't want to change the other tools. So if I was to say yes, it's going to change this tool, or it's going to change the other 2 tools that are both listed right now as tool number 1. They're going to get modified as well. So in this case, I want to say no. And so that'll be a different tool. Now for the finish pass on this, I'm going to go ahead and do an alternate finish, and I want to go both ways. So with the alternate option, the problem that I have with the continuous is if we start right here, as soon as we start getting into these walls where we got to work up, you got that big mess building up in front of your tool right there. Same thing with right here. You get into these corners, you just got this rat's nest building up if it's not breaking the chips right, and it just gives you a more marred up, bad finish. So what the alternate lets you do is it lets you go in and you could change it. You could say I only want to do the vertical walls, or I only want to do the turn diameters. But if we say both, I could have it do a standard kind of finish for any of my turn geometry, and then for the faces or the vertical geometry, have it come back and cut the opposite direction. So I'm going to go with both there, on with collision detection, using the holder, and then really nothing else is changing in here. It's just the default. So when I'm done, I'll hit compute. No again on that, no again on that, and we'll let it calculate. It asks me one more time if I want to change that tool setting. There it is. So it did not ignore the angled groove, as you can see. It did go in there, which again, I'm okay with that. This tool can handle going in there and cutting that. I'd prefer it not to, especially if I'm going to set up a tool on that specific angle already. But the only way to get around doing the angled groove would be kind of how we did it in the past. You'd have to go in. Let me blank that out. What I would probably do is I'd make a layer and call it angle groove. And then I would actually take the 3 sides to that. So that, and I would move them to that new layer. So I'd move them onto that layer, and then I could turn that layer off. So now I can come in and say create 2D, grab my line, and just join it from here down to here. All right, so just like that. So as long as I created that line properly, now if I go ahead and remove my old turn geometry and say reselect, whoops, didn't go to the end, got to go to the end of the first, or pick the first chain. Always pick anywhere on the first chain. You should be fine. Then I'm going to follow it to the end of the last chain, find the midpoint, and go past it. Then hold shift and click a second time. And again, as long as that geometry is good, it should chain all the way through there. When I'm all done, go ahead and hit OK. And then now I'm going to recompute, and we shouldn't have that groove getting cut in anymore. Whether you keep it or not is completely up to you. But yeah, there we go. So just letting it run. All right. Wow, this hour has flown by. I apologize, guys. I thought I was going to get through a lot more of this. Let's go turn, rough, finish. I want to do at least one of these grooves on here just to get a groove done. So I'll do both of these turn grooves. So I'm just going to right click. We're going to go down to the Lathe Groove, and I'm going to select my geometry. Now the geometry for the turn groove is every bit of the geometry that you want the tool to cut. All right, and that's important because if you have fillets or chamfers on the top edge of this and you want the finish groove tool to cut them, you have to make sure to pick them. So I'm just going to drag a box over all that geometry right there. I'm not picking any of the vertical or any of these horizontal lines next to it or in between it, just the grooves. Then I'll hit OK. Now, when we get to the next page, we have our OD, which is right. Now, down here is where we got to start thinking. We don't want this to start at the stock. If you look at the picture, it's trying to start it from way up here, but we've already removed most of that material. So I'm going to come in and say, let's go from the geometry, and then I'm not even worried about extensions. We'll do a groove rough and a finish. So it's going to give me a rough pass and a finish pass. Next, I'm not really worried about the posting. All right, on to the groove. So right now it's trying to pick this custom angled tool. Let me go in here and see if we have a better grooving tool. So right there, number 2, that's the one I'm going to pick. So I'll click that and hit OK. For whatever reason, it grabbed the angled groove tool, but that's the tool I want right there. So other than that, pretty standard. The rest of the settings are the same. Next, got our patterns. So when you're doing a groove, you have a few different patterns. The standard cut's just going to go 1 and just make a cut. Now, let me say, there is no real standard. The standard would be cut first, second, third, fourth, fifth. But we also have the ability to do center out. So you're starting here. You're going to go 1, 2, 3, 4, 5. Center out alternates is the alternate. And then skip. So you go 1, skip 1, 2, skip 1, 3. And then do your 4, skip, and 5. So you're going to come in, do it that way. I'm going to go with a standard. Now, if you ever had a tool that was custom, a custom groove tool, that you wanted to just go in, you wanted to cut into the part and then leave. Just one pass straight in and straight out. That's what you'll use the single pass for. Now, depending on kind of where you set up your origin on the part, not the origin, the theoretical touch off point, that theoretical tip, depending on where you place that, you'll have to choose whether you want to center it, go to the beginning, or go to the end of that cut. You can also do a zigzag to let the tool work its way down as a zigzag. I'm going to go with standard, and for my collision checking, I'm going to just make sure my tool holder is not hitting anything, and then go next. Right here, we got our step over amount, so you can set that up to really whatever you're comfortable with. The finish allowance, or really what we're leaving for the finish pass. You can also use this to do multiple depths, and so you can bring it down evenly. You don't have to go full depth. You can take it down one level, and then go back to the beginning, take it to the next level, and just work your way down. You can also do pecking. So you can have it go in and peck its way in. Your first peck amount's the amount you're going to take off on your first peck. The peck increments, the amount you take off per peck after that. And then the peck clearance is how much we retract in between each peck. So there we go. Right. And then trim to stock, not messing with that. So right here, we got our rapids, same as always. Leads, pretty well same as always. They got all the options, but with a groove, you can only start with a parallel lead in or lead out, because the groove rough is just going in and making straight lines. When we get into the groove finish, we'll see a few more. So here's the groove finish. I'm going to go back up to the tool crib, pick that same tool number 2, and then just next my way through. So force down cutting is going to make it go from both sides of the groove. You're going to come in from the right side and cut to the center, and then come in from the left side and cut to the center. You can even give it a small overlap. You could say, I want to do a 1/16 of an inch overlap there. The basic finish is just going to start on one side, cut straight across, and come back out. I'm going to do force down. Now, on with collision detection, I'm going to use the tool holder. No change for the parameters. We're doing a finish pass now. There's no fixing that, or there's no more stock that we got to save. And pretty much just next my way through until I can hit compute. Grooves don't take too crazy long to calculate. The difference is we have 2 grooves, so that's why you're seeing this box pop up a couple more times. You'll see it one more time after this. So it didn't finish the whole part. I didn't really have a plan to, because the problem with turning is there's nothing you can combine. I can't take up you can combine 2 grooves, but it's not like milling where I could say, with a 3-axis toolpath, go cut this whole part and rough this whole thing out for me. The turning, you have to break every single feature down and really get into it. So I'm launching the simulation right now. We're going to see how this thing looks. So when I watch my simulation, a lot of times I like to turn it to a front view, like so. It's kind of how I was drawing the part and doing everything else, so it kind of works. And one real cool tip, if you're doing any ID work, you can go to a front view, and then right here under visibility, you go over to your stock option, and you make it transparent. When you make it transparent, any ID work you do will show up on the inside kind of as a see-through thing. It's pretty cool. So I'm going to go back to my visibility. I'll turn my stock back on, turn the speed down a little bit, and then hit run. So we're going to come in, we're going to face it off there, and then we're going to start our turn rough and just kind of work our way down into that part. Then right here, we're going to start the finish pass, the groove, first rough, second rough, same tool. There's the finish coming from both sides.